Hi, in this video, I'll show you how you can use Python to control your Lightwing drones. Yes, you can write simple lines of Python code to ask your Lightwing drone to take off automatically, hover at a particular height, or even do mission paths autonomously. So there are three ways that you can control your Lightwing drone. Way number one is pretty straightforward. Right out of the box, power your drone on, connect it to your mobile phone app and fly it directly from there. That is a very basic approach where you can just fly your drone. The second way is more complicated. You can use the onboard Type-C connector that is shown over here, not only to charge this battery, but also to program the ESP32 microcontroller that you can see on the drone. So you can connect the drone to your laptop and use Arduino IDE or ESP IDF to write the complete flight control firmware from scratch. The third way and the most popular way to control your Lightwing drone is by using a Python script. So by default, the firmware on your ESP32 comes with a modified version of CrazyFly. So you can leave it as such. And then what you can do is you can connect it to your laptop using Wi-Fi. And here you can write simple lines of Python code to monitor various flight parameters and also to control your drone in real time. In this video, we're going to do exactly that. Also, in this tutorial, like I mentioned earlier, we're going to make this drone fly on its own, meaning it has to maintain its height and its position on its own. And in order to do that, you will be needing this flight positioning module, which you can see here. So this flight positioning module enables two features on Lightwing. One is the ability to hold its height, called height hold, and the other is its ability to hold its position, called position hold. So as you can see, there is a TOF sensor for height hold and there is an optical flow sensor for position hold. The drone that we are going to use for this demo will be using such a drone positioning module. Now you can also control your drone from Python without having this module. You can send raw values and ask it to, increase its thrust, change the pitch, roll and yaw values. But your drone will behave very unpredictable and you would have to have some kind of external element to maintain its height and position, which gets more complicated. So if you're a beginner, the drone positioning module is definitely recommended. So in this tutorial, I will show you how you can install the Python library and I will show you 3 levels of code in increasing difficulty, allowing you to control your drone autonomously. By the end of this video, you will be able to make the drone fly on its own, maintain its height, move in a particular direction for a particular distance and all that stuff. Think about it. Once you master it, and since it has the power of Python, you can use your onboard webcam or microphone to make your drone move based on gestures or even move based on voice commands. Or you can have an external sensor somewhere in the room like a UWB sensor, GPS RTK, or anything that you desire to send values to the drone. So this way you can monitor all the flight parameters and also control your drone's performance. So it opens doors to a lot of interesting projects. That being said, this is Ashwin from Circuit Digest. Let's get started. Okay, so for this tutorial, the most important documentation that you should refer to is called the Lightwing Drone Python Library documentation. Over here, you can see all the instructions. Let me run them over one by one and show you in this video how to do it so that you can follow along. So the first thing is we have to clone into this repository called Circuit Digest Lightwing Library. So I want to just copy this link, and for the sake of demonstration, I'm going to use PyCharm, but you can use any IDE of your choice. So here I am on a new project on PyCharm and I'm going to open my terminal over here. And in my terminal, I want to just paste this command and click on enter. You can see we are cloning into the repo. And once that is done, we have to go back to the documentation and you can see various commands given to install it on a Windows machine, Mac OS or Linux. I'm on a Mac, but if you are on Windows, just click on this link. You can actually download this from here. Like you can download a zip file, and once you have downloaded a zip, extract it, and then you can directly click on this install.bat and it will install all the dependencies as well as the library. So doing it on a Windows is much more easier, so you can directly follow those methods. But if you're on Mac or Linux, the instruction for that is also given over here. So now I'm on a Mac, so I have just cloned into this repo. If I do ls, you can see my repos there, Lightwing library. So I'm going to get into that. And once I'm in there, I'm going to do pip install and it should install everything that is needed. So now back to PyCharm, we can see that successfully installed Lightwing 0.1.1. Let me do a quick pip list to check if my Lightwing is installed. So yes, my Lightwing library is installed over here. So now that our library is successfully installed, the next step that we have to do is try an example code. So to do that, let's go back to our documentation over here, which I showed you earlier. And then there are three levels of code that you can try. So the first level of the code is just to connect to the drone and read some sensor parameters from the drone so that we know everything is working well and our communication is also happening flawlessly. So on level one, we are just going to read sensor value. So let me just quickly copy this code. I will explain this code real soon, but let me first try and show you how to run it. So here, as you can see, it's showing some error that Lightwing library is not found. So the reason is that it is running this program using Python 3.13, which is why it's not working. So what we are going to do is we're going to run it manually from the terminal by doing Python 3.11. Now, when you install the library, Python 3.11 would have already been installed, so you don't have to install it separately. So Python 3.11 and then main.py, and this will actually run our code without any error. As you can see, it says connecting to UDP, but it is not going to work because my drone here is not connected to the laptop yet. So now that we know the library is working correctly, let me connect this drone to this laptop, explain this code and show you how it works. Okay, so we have our drone over here with the positioning shield already connected to it. So I'm just gonna turn it on. And as you can see, I've also written AD on this drone, which is the last two digits of the SSID for this drone. Since we have many drone, I didn't want to confuse. So this blue LED blinking indicates that it is ready to pair. I'm going to go to my laptop and look into the Wi-Fi. As you can see, there is a SSID called AAD ending at AD. So I'm just going to connect to this drone. So once it's connected, you can see that the drone starts blinking in green, saying that it's already connected to the laptop. And you can also notice that this green LED blinking in a particular frequency, showing that everything is working as expected. Now for the code here, what we're going to do is we're just going to import Lightwing from Lightwing. And then we're going to use this IP address to connect to the drone. So all the Lightwing drones by default are at the IP address 192.168.43.42. So that's what we have used here. And then we have used the command called drone.connect to connect to the drone. And after 2 seconds of interval, we're going to read the battery voltage and print it. And then we're going to read the height of the drone from the ground. So we have a TOF sensor over here. So we're going to read the height of the drone from the ground and print it on the serial monitor. And then we're going to disconnect from the drone. So yes, a very basic code, but this will help you to do two things. One, if your library is installed correctly, you'll be able to verify it. And the second thing is you will be able to tell if the communication with your drone is happening correctly. So now I am going to execute this code the same way I told you earlier, Python 3.1.1 main.py. If I click on enter, you can see connecting to that UDP address. And then we can see that the code tests for the TOF sensor and the optical flow sensor over here. So yeah, every time you run this Python code, it's going to check if there is a TOF sensor and an optical flow sensor. So based on that, it's going to change few ways on how it's going to work. So in our code, it has already tested for TOF sensor and optical flow sensor from this shield, and it is able to get those values. And then here you can see the battery voltage being printed, which is 4 volt, and the height which says 0.11 meter minus 0.11 meter because it's still on the ground. So which is almost equal to 0. So 0.011 meter. So that is also fine. And then it's just saying disconnected and it just finishes the program. So yeah, this is a very simple code where you can read parameters from the drone and display it on your terminal. Not just drone battery and drone height. There are multiple values that you can read from the drone using this Python code. In fact, if you scroll down this documentation, you will see all the different parameters that you will be able to read if you scroll all the way down. Yeah, sensor data class, you can read a lot of values such as velocity in x-axis, velocity in y-axis, the roll, pitch, and yaw values, battery, delta x, meaning how much the drone has moved in a particular direction, accelerometer x, gyroscope x, y, z, and a lot more values. So under level 1, we have shown some pretty basic example codes like reading sensor data. So if you go back to the GitHub library, get into examples and level 1, you will be able to see much more example codes in this same domain. Now let's move on to level 2. Okay, so now things are going to get interesting because in level 2, I'm going to show you how you can use the Python script to make your drone automatically take off and hold its position for 3 seconds and then land on its own. So to do that, I have used this sheet here with a lot of patterns because the optical flow sensor needs some kind of pattern below it to track the position. The table is purely white and the floor is also white, which is why we have used this sheet. Now on the program side, we'll go back to the page, and if you scroll down, you can see level 2 first flight. So this is the code that we are going to use for demonstration. I have copied this code and pasted in my IDE already. So what basically it does is it's going to make the drone take off at 0.3 meters and hold its position for 3 seconds. Now what I'm going to do is I'm going to run this code, but before I do that, let me also make sure my laptop is connected to the drone. Yes, it's connected. I'm also going to use this camera over here to show you the drone flying in close-up. So the drone is already connected to my laptop. I'm just going, so I'm going to use Python 3.11 main.py. So basically executing the same code again. So once I click on enter, you can see the laptop is connecting to UDP and it communicates with the drone. And it is going to make the drone take off automatically on its own and hover there for 3 seconds. So it is holding its position for 3 seconds and then it's going to land on its own automatically. So now let's take a look at the code which we have just executed. So starting we have made, like I told you, the target height is set at 0.3 meters, which is 30 centimeter, and the total hover duration is 3 seconds. Now after that, we are going to drone.connect to connect to the drone. And then after 2 seconds, waiting for the laptop to connect to the drone, what we're going to do is we're going to check the battery voltage. So many times when we are doing complex programs or making the drone to follow a particular path, if the battery is low, things are not going to work. So it's always better to check the battery before you execute the code. And then we have also done one more extra thing here, which is drone.set LED color. So the shield here has 4 neopixel LEDs on the back. So you can use these LEDs to indicate any error or indicate the status of the drone. What we have done here is we have set the drone's LED color to green. So this is eventually RGB, so 0. And for green, we have put 255, so maximum brightness in green. And then we are going to wait for a second and then we're going to print arming and arm the drone, and then we're going to take off the drone at the target height which we have set earlier, and then we're going to hover there for the duration which we have set earlier, and then finally land. So yes, this is a simple code in level 2 where you can make the drone to take off, maintain the height and land on its own. Now let's move to level 3 where the drone will not only just take off, but it will follow a particular path and then land after completing the mission. Let me show you that in action as well. Okay, so now for level 3, we are here at PID tuning and waypoint. So what this basically means is this Python script also allows you to tweak the PID parameters of the drone if required, not needed for most users, and also set waypoints, meaning the drone will take off, complete the waypoints what you have said. For example, make a square pattern, or even think of it as a geometric plane where you define where the drone should move after one point after another. It will move through all the waypoints and then land on its own. So this particular code here shows exactly how to do that. I already copied and pasted over here. Let me quickly explain this code. So here you can see that we are connecting to the drone, pretty much the same thing which we have seen earlier. One interesting thing here is drone.start logging. So what happens is many a times when you're trying new things, you might not see the drone do what exactly you're expecting it to do. So it's always easy to understand why it behaved that way by looking at the flight log. So by doing start logging, it's going to log all the important parameters inside a file called waypoint underscore flight, and then we're going to arm the drone, and then we're going to do a takeoff. And then we have shown 2 methods of controlling the drone while it's hovering. So what we basically do is think of it as a graph. We tell the X and Y point and the speed at which it has to move towards that point. So when you're controlling drones or robots, the X and Y axis might be a bit different than what we have learned in geometry class. For example, normally when we draw graphs, we do X axis like this and Y axis like this. But in robotics and drones, you have to use the right hand rule. For example, if you point it like this will be your Y axis, and this will be your X axis, and this will be your Z axis. So for a drone which is placed over there, you have to think of it like this. The forward direction is X positive, the left direction is Y positive, and the upwards direction is Z positive. Since we are going to just use the optical flow sensor, we don't have to worry about the Z. So we'll only think about the X and Y direction. So this is X positive and this is Y positive. Now coming back to our code, when we say drone dot fly to, this is X and this is Y. So 0 is our X position and our Y position is 0.5, meaning it will move towards the left for 0.5 meters and at a speed of 0.3. And then it shows drone dot fly to minus 0.5 to 0, which is the next coordinate, and the final coordinate is 0, 0, which was the initial place we started. Thus, it is going to form a triangular pattern after it takes off. So this is method 1. The second method is to define all these coordinates predefined in an array. So say for example, if you want to do a square pattern, we're going to do this kind of thing. So 0, 0.3, minus 0.3, 0.3, minus 0.3, 0, and then 0, 0. So this will form a square. So by loading an array and then using this function called drone.position and passing this array, you will be able to make a square pattern. So now let me execute this code and show both of that methods in working. Okay, so I have shifted the camera to the phone to show you the working. As you can see, the drone takes off and makes a triangle pattern now. And the next step, it's going to make a square, move forward, go left, come back, and then come back to the initial position and land. So that's it, guys. These are just few things that you can do with the help of this Python library. Actually, the library is capable of doing so much more, especially if you're building something unique or if you're trying to add more features to Lightwing. The library would come in very handy because it can read all the important flight parameters and sensor values and help you to debug with any new logic that you're trying to implement. So just scroll down this documentation and you can have a look at all the different properties and methods that you can use with this function. Say for example, you can connect to the drone, disconnect to the drone, and you can check if your drone is connected, is flying. You can check the status of the flight, and you can also check the different sensor values like I mentioned earlier. You can control the drone with various flight commands like hover, land, emergency stop. The emergency stop will also come in very handy if you're trying out new stuff. Say for example, if you press the enter key, the drone should come into an emergency stop, and that way you can prevent the drone from crashing into anything. So yeah, now it's up to you to figure out what you should do with this Python library and what you want to make your drone to do. So few examples that I already gave you earlier at the starting of this video is to use OpenCV or media pipeline and do some kind of gestures to control the drone, or use your voice to control the drone. We are also building a few more tutorials which will be available on Circuit Digest very soon. So yeah, the Python library, everything you can possibly do with it is explained in this documentation. The link for the same will be in the description. So let me know what you guys think. If you want us to build anything in particular, do give us suggestions and we'll consider doing it. Also stay subscribed to this channel so that every new project that we build with Lightwing reaches you as soon as possible. That being said, thanks for watching. Have a good day. Tata. Bye-bye.